Our last example is number 21 from section 3.3. So two freshmen at Cal Poly, the college out in California where some of your authors are from, gathered data on prices for a random sample of 30 textbooks from the campus bookstore. They found the average price was $65.02. Standard deviation of prices was $51.42. The data were not strongly skewed, so we're going to find and interpret a 95% confidence interval for the parameter of interest. So once again, I invite you to pause the video and see if you can come up with the observational units, the variable, and the variable type as a place to start. The observational units in this case would be the 30 textbooks, so they're not people, they are the books, and the variable is the price of the book. Notice it's not average price, it's just the price. So they look at textbook number 1, what is its price? Textbook number 2, what is its price? They go through the whole set of 30 books, and each book has a price with it. That's the piece of data that they collected. And of course, this is a quantitative variable, something that is measured. Next, we should kind of go through the data that we were given in the question. So we were told the statistic X bar sample mean was 65.02, and S, the sample standard deviation, 51.42, and N, the sample size, in this case, is 30. And here again it says find and interpret a 95% confidence interval for the parameter of interest. So we were not lucky enough to be given that parameter written out in words so we could copy it like we did in the first two examples. Since our variable is quantitative, that parameter is a mu symbol, and we know it's a population mean. This would be the mean or average price of all books in the campus bookstore. So again, that's textbooks. So once again, the parameter is about the entire population. They collected a sample of 30 textbooks and they got a mean price for their sample, but what they're trying to do is come up with a set of plausible values for what the average price might be for all the textbooks in that bookstore, the entire population. All right, so to create our 95% confidence interval, again, that is the statistic X bar, plus or minus. We're using a multiplier of 2 because we're doing 95% confidence, 2SD method, times the standard deviation of the statistic, or the standard error, which is S, the sample standard deviation, over the square root of N, the sample size. So we're going to plug all the pieces in. 65.02 plus or minus 2 times 51.42 divided by the square root of 30. That is the sample size in this case. And again, I strongly encourage you to actually do these calculations for yourself. Pause the video, do the calculations, make sure that you can get the correct answers. Let's start with just the SE, standard error value. If you take 51.42 and divide by the square root of 30, you should get 9.388. Then you want to multiply that by 2. 2 is our multiplier in the 2SD method, and you should get 18.776. So at this point, our interval is in the form statistic plus or minus a margin of error. So the margin of error in this case is 18.776. Then we're going to do a subtraction, 65.02 minus 18.776, and we're also going to do an addition, 65.02 plus 18.776, and you can put each of those into your calculator and you should get 46.244 from the subtraction and 83 0.796 from the addition, and that creates your 95% confidence interval, 46.24 up to 83.80. Now we should interpret the interval and the sentence pattern. Hopefully you're already starting to get used to it. We are blank percent confident, and I'm filling in the blank with 95% because that was the confidence level we were given in this case. And now here's where having figured out the description of the parameter is coming in handy, because that's what we want to put in next. The average price of all textbooks in the campus bookstore So keep in mind that the confidence interval is about the parameter that applies to the entire population. It's not about the sample statistic. It's about the parameter for the entire population. So we took a sample of books, we found the average price in our sample, and then we're using that with our margin of error to come up with an estimate of plausible values for what the parameter mu might be. So we still don't know the exact value of the parameter. It is unknown, but now we've narrowed it down to somewhere between 46.24 and 83.80. So we finish our sentence with is between, and we put in the left endpoint of the confidence interval and the right endpoint of the confidence interval. Whoops. And especially when our variable is quantitative, we should make sure that we include units. So these are prices, and they should have dollar signs. So again, we don't know the value of the parameter, but we've narrowed it down to being somewhere between 46.24 and 83.80 is the average price for all the books in that bookstore. Okay, we can also potentially do a theory-based method. And in this case, we were told the data was not strongly skewed, and we had a sample size of 30, which is more than 20. So the answer is yes. The sample size n equals 30 is bigger than the 20 that we need, a minimum of 20. And we were told, we didn't get to see the data, but we were told that the data were not strongly skewed. So that means it's okay to use a theory-based method. So we're going to go to the applet and put in the new information for this scenario. So our sample size is 30. The sample mean in this case was 65.02, and the sample standard deviation in this case was 51.42. And again, if we hit calculate over here on the left, then the confidence interval is updated automatically. So in this case, the theory-based confidence interval is 45.8195 up to 84.2205. So the theory-based confidence interval $45.8195 up to 84.2205. So once again, it's good to compare the theory-based to the 2SD by hand method, and they are very similar. They're not exactly the same. We don't expect them to be exactly the same. The theory-based is based on, just as it says, theoretical models. And the 2SD method is using a multiplier of 2. The theory-based method is using a multiplier that's a little bit different than 2. But they are very similar, and that's because the theory-based confidence interval is valid, is appropriate. It's close to the 2SD method because our validity conditions were met.